Thank you. Yeah, so this work was initially motivated by EU directives. So that's mainly Marine Strategy Framework Directive that promote the sustainable use of the seas, but also they want to make sure that these human activities are then in line with the good environmental status of the sea. And this Marine Strategy Framework Directive, it has like a long set of different descriptors of the marine environment and the status of the marine environment. But here I only focus to this descriptor 6, which is the seafloor integrity, that really is focused on the seabed or seafloor as such. So until now there was no indicator or a tool to assess if the seafloor's seafloor geology or physical sedimentary structure, whatever you want to call it, if it is in its natural state or if it has been changed by human activities. So we wanted to develop that. And of course the metrics of such an indicator should be based on very simple parameters in order to have cost-effective monitoring programs in the future. So the key concept here is seafloor geological integrity, which means the capability of a seafloor to provide a habitable substrate for indigenous benthic communities. So to begin this method development, we went to the Vaasa offshore dumping area here in the Gulf of Finland, actually. So it was used during the constructions of the Vaasa harbor in Helsinki, and the activities there ceased some 10 years ago or so. And we went there with our ship that Jyrki already showed this picture earlier. So we have different kinds of seismic survey systems there. But in this particular study, the multi-beam echo sounder, so it's this fan here, was particularly useful. And we also can collect sediment samples with on board on the ship. Okay, so the field work. So here on the top right, we have the bathymetric image produced by the multi-beam echo sounder. And here on the lower right is the backscatter of the multi-beam signal, or the reflectance of the seafloor, if you like. So that gives an impression of the hardness of the seafloor substrate. And actually these brighter patches, what we see here, these are the mounds of the dumped material, quite well visible. And we also collected sediment cores in this grid pattern over the dumping area. And the dumping area is actually outlined by this pink line there. And the sediment cores, we measured them for cesium activity and then weight loss on ignition, so that's a proxy for organic content. And then also we also measured grain size distribution. That's actually a very helpful parameter in this case. So how does the dumped material then look like in the sediment cores? So it's normally it's present as a layer of gravelly mud. In this particular core, it's a superficial layer that is about 2 centimeters thick, and it has a massive texture and angular coarse grains. So these guys here, so they are really sharp angular grains. And then looking at the grain size diagram, so here on the x-axis we have the mean size of these sediment grains in a particular sample, and then here on the y-axis we have sorting. So that's when you have well sorted sediment the sediment grains are more or less of the same size. But when you have poorly sorted sediment, then you have basically a mixture of various kinds of grain sizes. And so we are here on this poorly sorted range. And here on green, we see samples that are from natural sediment. And then these black dots here, they are from dumped material. So what we see is that this dumped material, it's coarser, and it has a broader mixture of grain sizes. So what this really reflects is that we have the natural sediment, and then we have admixing of rock, pieces of rock that were then blasted during the dredging operation. So there are pieces of bedrock and pieces of boulders that are then admixed in the natural sediment. And they stand out pretty nicely in these diagrams. Okay, so we were quite happy because we could now see that the dumped material, you could tell it apart from natural sediments based on these multi-beam backscatter images, and also in sediment cores. So we want to then go and test if we can see if this works also in another dumping area. And then we went to Uusikaupunki offshore dumping area D, to be precise, actually. And this was in use pretty recently, so it's 2013 and 2014. And we did the same things basically. So we made a multi-beam survey over the dumping area here, and this is the backscatter image. And again, we can see that there are these brighter patches, and then we took 6 sediment cores this time, and then the sediment cores, the red ones, where we have dumped material, they really plot on these brighter patches in the backscatter image, so that there is a clear connection. Also, what is interesting is that here on this multi-beam bathymetric image, we see that some of this dumped material has actually slumped down to a channel which is running like this. So it has not really stayed on the dumping area as it was supposed to. Okay, so in principle it seems that we have a method which is working on 2 different areas. So we wanted to take this further and test it if this method can also be used for assessing the recovery of seafloor geological integrity or the state of the seafloor. So here in this particular core we have the dumped material, so that's the gravelly mud unit here, which is then covered by 5 centimeters of natural sediment. So this means that the dumped material has been buried already a little bit, so there is some recovery going on. What is interesting is that, and especially for the Baltic Sea, is that the benthic communities, they are dominated by small organisms because of the salinity stress mainly. And so for these little fellas, the already fairly thin layer of natural sediment on these dumped materials, we actually make the seafloor appear like a natural substrate. So we picked this rule of thumb that when the seafloor is covered by 10 centimeters, then it's more or less a natural seafloor for these guys. But of course, this kind of recovery is only possible in areas where you have sediment deposition going on, which is not nearly everywhere. So it's only at some fairly specific locations where you can expect this to happen. Yeah, okay. So I'm now moving to the final slide. So this is actually the assessment protocol. So it has 2 methods. It's acoustic surveys, which is the sort of quick method to check if you have dumped material, or if those, and then if you repeat the surveys, then you can check if the dumped material mounds are being covered by natural sediment. And then there's the sediment core analysis, where you can then be more accurate. Yeah. And then regarding these 2 sites that we checked, Vuosaari, there is some recovery going on. Uusikaupunki, that's not recovering, and the dumping site probably was not chosen in the best location. Okay, thanks for your attention.